So now let's start with another video in which which we are going to see how we can plot an impulse function. So, and again, ampersand I'm using, or the percent sign. You can go to the editor, an impulse function. So, which you must know that it is equals to 1 at t equals to 0, and for the remaining it's equals to at 1 t equals to 0, its value is infinite, or you can say the upgoing arrow, and the remaining it is equals to 0. So let's say, suppose I define time equals to t equals to minus 10 to 10. You know the default value of this is this. Let me clear my command window. So one more thing is that if you are using a semicolon with it, so when you run the program, nothing is going to appear. I'll show you it in the end when we will use this. Then t equals to this, and suppose I'm saying y is equals to Dirac. So delta Dirac is the name. So you use this. You write t for this plot, and you say t comma y, and when you run it, so you can say that this is coming as 0 for all these values, and then it's coming, there's a gap, and then there's a again 0. So why it's not showing it? Because there's a value infinite here. So if it's a continuous time signal, so the MATLAB draws straight line between 2 points. When I'm saying straight line between 2 points, it basically works in this way that at minus 10 the value is 0, at minus 9 the value is 0, so means the y axis value is 0. So that's why it is straight line between these 2 points, all these points, and then it's infinite, and then it starts from 0 again here. So in this way this is getting plotted. If you use stem, then you are basically plotting the impulse function but in discrete time domain. So you will see that now it appears in this way, that at minus 9, 0, these circles are showing that the value is 0 here. Again, the t is the same and the value here is infinite. Now I want to tell you what's the use of using semicolon here. So suppose I put a semicolon here and I don't put a semicolon here, and I run it, then you will see that I'm getting the value of y only, because there's a semicolon here, means when the program will be run, so the values of these lines are not included in the command window. So if I mention, let's say again here, so when it will run, let me make it clear again, and I run it again, you will see that nothing is coming. Now if you want to see the value of t, you have to type t. You want to see the value of y, you have to type y. So in this way these functions works. Now if I want to create a unit step function, so there are two ways of doing a unit step function. So the first one is using a function which is defined already in MATLAB, which is heavy side or heavy side, sometimes people say, unit step function or unit step signal. So again I'm using time is equals to, let's say, minus 10 to 10, and I say y equals to EV side t. Let me clear command window. I run it. I forgot to save it. So let's say save. Then I run it. So you can see that From minus 10 to total columns are 21. Why the total columns are 21? Because there are total values 21. Minus 10 to 10 means including 0. So it's minus 10 on negative side, plus 10 on positive side, and there's a 0 in between them. So that's why the values are total 21. From minus 10 to minus 1, the value is 0. And the further on, it's 0.5, 1, 1. Now, there's a problem using Heaviside function. So at t equals to 0, this value is at t equals to 0. It takes a value equals to 0.5. So if you want to make sure that it uses a value 1 at that point, you need to use sim preference Heaviside origin, comma 1, and then you run it again. So it's giving again equals to this. So I think I need to type it capital here. So if we run it again, then you will see that at this, the answer is 1. So answer is equals to 1 means it changed the value here. So sim preference is this, and suppose we stem it from t to y, and then we run it again, then you can see that the value at 0 is 1 now instead of minus 1. So if you don't use this and you make it percent and you close your window, you run it again, you will see that it's taking the previous value. In stem it is taking this, and you say CLC, so the value is half for this from minus 10 to 10. If I write plot here, so it's plot t comma y, I run it. You can see that when you are running a plot command, it's going from minus this to this. So if you want to make sure that this is 1, you need to use this sim preference, run it. So in plot command, there's a straight line from minus 1 to 1, and it's not making it's not telling that the answer here is something not a perfect unit step function, and the reason is that because the value at minus 1 is 0 and the value at 0 is 1, so the MATLAB draws a straight line between these 2 points. That's why it's like not a perfect unit step function. And there is another way of doing it. Another way of doing this thing is that we use, let's say, our time, let's say as your minus 4 to taking small values 0, 0, 1, and then colon we are using 5 and 5, and we are going up to 5. Then if you are generating this, instead of using Heaviside function, so we use a function which is your sine something function. You will see it how it's going to react. So sine x, you are calling a function plus 1. Make sure that you close all the brackets which you open, and let's say a plot t comma y, and then we run it. So I think we did t comma y. Oh, sorry, I used x, so it should be t. So editor, run it. So we have a unit step function plot. You can see it is 0 and it's going on negative side. So this is the unit step function going from 0 to negative hand side. So if you want to plot on the negative side, so if you don't use a minus sign here, and you close your previous window and you run it, then it will be on 0, and it's a perfect unit step function. So you can use this function sine. We are going to use that further to plot your ramp function and your square wave. So control C, I'm using this, going to use the same values. That's why I'm scoping them. And let's say we want to use a ramp function with it. So ramp function means basically you are multiplying it with a triangular function, or you can say we are multiplying it with a line. So dot, remember now we are using a matrix. This is also a matrix, sine t, and this is also a matrix. So you need to use dot star. So sine t plus this, and you need to use same for negative side also. So it's t minus 1, and it is t plus 1. So it is, if we run it, sometimes we need to go back again. If there's any bracket which is not closed by me, save it, we run it. You can see that there is a triangular wave for the negative side, starting from -1 and ending at 1. So in this way you can plot a ramp function. So let me name it. So it's percent ramp function. If you will remove this part from here and if you run it, you will see that how it's going to appear. So it will be this ramp function only, starting from -1 and going up to 5. So if I use it again and then run it, you can see that there are two ramp functions which are basically subtracting. So if you remember the equation of lines in maths, coordinate geometry, so it's similar to that happening in the form of MATLAB. So let me make it subplot so that we can have triangular and square wave together, 2 to 1. And then copying this part again for your square wave or function. So it's this. So you need to create a square wave. So then it will be, you will not shift it because it needs to start from, let's say t equals to -1, -2, not t plus 1. There is no shifted version of that. So then it will be +1 divided by 2. and this will be, let's say, from t minus 2 divided by 2, and I say subplot 2. So you run it again, so you will see that we'll have two waves. One is of this form and another, this is again a kind of square wave. Sorry, this is another kind of your ramp function, and the reason is that we forgot to remove this t from here. So it's making it a ramp signal again. So that was another form of ramp function, you can say. Invalid use of operator where we use an invalid, yeah, it's here. Remove it. I'm doing it in the form of like in the real time so that you understand how you face problem while you run the programs in MATLAB, and then you can see how to find the errors also. So in this way you can plot a square wave also. So this is basically one part of the square wave. So if you need to do the another one, so it start from, if you see, it run from, it ran from 0 and ending at 2, and here you can see it's 0, basically t minus 0, and this is t minus 2. So if you need to make it goes to the negative side, and you need to say plus, then you make it t minus 2, make it minus here, make it plus here because you need to change the sign, and this will be t minus 4. You run it again, you can see that it's a square wave. So when you have to at 0, it will be t. If you need to make it at t equals to, let's say, minus 2 on the axis, then you need to make it this thing equals to plus 2. This will be, suppose we're making from minus 2 to 0, then it will be this form. Let me close it so that you can understand it better. So now if you run it, you can see that there is a square portion from minus 2 to 0, and then there is another square from plus 2 to plus 4. However, the polarity of this is opposite. There is a minus sign I put before this and this, so that makes the polarity equals to change polarity here in this section. If I make it plus here and a minus here, then the polarity will be, you can see it's like this. Okay, if you want to make it perfect square wave in this, then make it 2, this equals to 2, run it again. So it's now this, but it's from minus 2 to 2. And what we need to do? We need to do it on the negative side so that it looks a perfect square wave. And we make it like this. Run it again. Close it. We run it again. And see, it's a perfect square wave. Starting from minus 2, going up, coming at back at 0, going from 0 to minus 1 in amplitude there. And if you want to change any amplitude, you can just put whatever amplitude you want here. That's a 2. It's a constant, you can put directly. If it's a variable, it's better to always use a star. must use a star in MATLAB. So if you see whichever you will put as a star, the amplitude will be different. So the amplitude here is 2 and the amplitude here is 1. So default is 1. So thank you for watching it, and I'll keep on updating some more videos regarding MATLAB, how to use it in a very, can say, useful manner and without any confusion. I try to explain things with respect to the shifting and scaling. So if you are shifting in MATLAB, you mention it minus here, it's on the positive side. The shifting on the right hand side means positive, or right hand side, use a minus here. If it's on the negative side, or you can say left hand side, then you will use a plus sign there. Thank you.